All right. So looking at upper bounds and lower bounds in inequalities, the first thing we need to understand is what is an inequality of this nature, right? And what is an upper bound and lower bound actually? So an upper bound and lower bound is the maximum and minimum value, the biggest and the highest and the lowest. So the lowest is minimum and the upper bound is your maximum that a number can take on. Right? That a number could have been, and this is the crux of it, before it is rounded to that particular whatever number. They're also called limits of accuracy. Okay, so it's called limits of accuracy. All right, let's suppose I have a rectangle. All right, suppose I have some kind of rectangle, and I'm told that the width of this rectangle is 3.2 centimeters. And I'm also told that the length of this rectangle is 8.5 centimeters. And they tell me that this rectangle, length and width, all right, in this rectangle, the length and width is rounded to one decimal place. And this is an important part of the question because so one decimal place means that because of the ability for a number to round to one decimal place, we have possibilities involved. We could have a number on this side like 8 point to one decimal place like 8.49, right? And that would be valid, right? We could also have a number like 8.48, 8.47, 8.46, 8.45. The moment we go to 8.44, it doesn't round. So that's not a possibility. But we know it definitely starts from 8.45 and it works its way up. And we could then end up with 8.50, 8.51, 8.52, 8.53, 8.54. That would all round down to 8.5. The moment it becomes 8.55, it goes to 8.6 and it's out. So here we have a lower bound and an upper bound. Our lower bound, which I'm going to call, let's say L, capital L, and U for upper bound, we said is the lowest number that 8.5 can be, such that if you round it to one decimal place, it would end up back there, and that would be 8.45. And the upper bound is going to be 8.54. And we can see that those two values technically round up there. But if we have to write it as an inequality, we could also have 8.544, 8.545, 8.546, 547, 548, 549, getting closer and closer to 8.5. So technically, we could get numbers that get closer and closer to 8.5 but never reach there. We can include 8.45 and we can exclude 8.5. So I could actually write this as an inequality. And this inequality would look like this. It would be the length can be greater than or equal to 8.45, any number from 8.545 onwards, excluding 8.55. And from there, you can see that excluding means that it's every number before 8.55. So if you have 8.55, it's going to be all the numbers to the left. And 8.45 would be all the numbers to the right. And any number in this region rounded up would end up at 8.5. And so this is my limit of accuracy, given that it's rounded to one decimal place. Now, there's a certain method you can see in creating this as well. If you take one decimal place, which is the same as 0.1, and you divide it by 2, it'll become 0.05. And if you take 0.045, 0.05, and you subtract it from this number, it would become 8.45. And if you add it to this number, it would become 8.55. So there's a method we could use where we're saying this number here is calculated by taking the original number and subtracting 0.1 divided by 2, which is that. And this one over here is 8.5 plus 0.1 divided by 2. So we could use a method of this, and we mustn't forget that this one over here is strictly excluded. So 8.5 plus 0.1 over 2, and that would be my upper bound, and that would be my lower bound over there. So the upper bound is technically not 8.54, it's 8.55 from this. Okay, let's look at the width now. The width has the same concept attached to it as well. The width is 3.2, and we know that it will be greater than or equal to or less than a number. Let's use this method here. So I take 3.2 and I plus 0.1. Oh, I got a minus because it's a lower bound. Minus 0.1 over 2. 3.2 plus 0.1 over 2. This would become 3.2 minus 0.05 less than or equal to W less than 3.2 plus 0.05. And from this over here, subtracting that, I get 3.2 minus 0.05 comes to 3.15. And 3.2 plus that would become 3.25. Okay, so that would be my lower bound and that would be my upper bound. And what you notice is the distance between the two is 0.1. The distance between those two numbers is 0.1 as well. Okay, so I've got this upper bound and I've got this lower bound, 8.5 and 3.2. That means I have different variations of the rectangle that I can have. So I've got my original rectangle, which we're saying is 8.5 and 3.2. If I want to maximize the area of this rectangle, then I need to have a maximum width and a maximum length, right? So which means that if I had to actually draw this, given that it's still rounding to one decimal place, then I know this can go to 8.55. I know this can go to 3.25, and that would be my maximum length and maximum width. If I want to minimize the area, then I can use the lower bound. And I can take that and use the lower bound calculations on each part to get to lowest possible area, which would be 8.45 and 3.15. If I calculate this original area using a calculator, given it's in centimeters, 8.5 times 3.2 is 27.2 centimeters squared. Whereas this one here will be 8.55. Let's see how it changes, if it does change dramatically or not. And this becomes 27.79 to 2 decimal places centimeters squared. And if I change it to 8.45, 3.15, comes to 26.62 centimeters. So the area becomes 26.62 centimeters squared for that party as well. And so we have our maximum area possible, and we have our minimum area possible, and we have our original area possible, given that we are rounding to one decimal place. That's all we needed to know. And from that, we could get so much information from all of those particular examples. Okay. I'm going to give you a rectangle now, and I want you to try it, right? So here's a rectangle. Okay, and it's rounded to one decimal place. So given the rectangle with length and width rounded to one decimal place as well. Suppose this is 7.9 centimeters and this is 5.4 centimeters. See if you can get me the maximum area possible and the minimum area possible, and maybe just sketch it quickly as a rectangle, getting your bounds correct and getting the areas correct as well. Okay. Try it when you're done and we'll go through it. All right, so the first thing what we need to do is identify what our upper bounds and what our lower bounds are for these. Looking at the first one over here, you can see that because we're rounding to one decimal place, we know that this can go as high as 7.95 and it can go as low as 7.85. And we know that this can go as high as 5.45 and as low as 5.35. We could write this as inequalities, where we have L is greater than 7.85 but less than 7.95. To ensure rounding takes place perfectly to 7.9, we need that inequality to be strictly less than. And the width, likewise, greater than or equal to 5.35, including 5.35, because when you round it, it goes back to 5.4. Excluding 5.45, and then from here, if we take the maximums, which will be 7.95 and 5.45, we could get the maximum area. And if we take the minimums, 7.85 and 5.35, we could get the minimum area for each one here. So we calculate this by multiplying the two together on a calculator. So 7.95 multiplied by 5.45 comes to 43.33 centimeters squared. And then 7.85 multiplied by 5.35 comes to 41.99, which actually rounds up to 42 in this one. All right, it's actually rounds two decimal places. 42.00 centimeters squared.